Download this code from codegive.com, link in the description below. OK, let's dive into the one-line Hamming code implementation in Python. This is going to be a bit of a misnomer because achieving full error detection and correction in a true one-liner is extremely difficult to make readable or maintainable. We will aim for a more readable implementation that still compacts the code significantly compared to the more verbose traditional approaches to coding Hamming codes. Understanding the foundation, Hamming codes, a quick recap. Before we jump into the one-liner, or, rather, highly condensed, version, let's refresh our memory about Hamming codes. One-purpose Hamming codes are designed to detect and correct single-bit errors in data transmission or storage. 2. Redundancy they add redundant bits, parity bits, to the data to achieve this. The placement of these parity bits follows a specific pattern. Parity bits reside at positions that are powers of 2, 1, 2, 4, 8, 16, etc. 3. Calculation each parity bit checks a specific set of data bits. The set of data bits checked by each parity bit can be determined by representing the parity bit's position as a binary number and looking at the bit position set to 1. For instance, parity bit 1, binary 0001, checks bits at positions 1, 3, 5, 7, 9, 11. Parity bit 2, binary 0010, checks bits at positions 2, 3, 6, 7, 10, 11. Parity bit 4, binary 0100, checks bits at positions 4, 5, 6, 7, 12, 13. Parity bit 8, binary 1000, checks bits at positions 8, 9, 10, 11, 12, 13, 14, 15. For error detection / correction when data is received, the receiver recalculates the parity bits. If the recalculated parity bits don't match the received parity bits, it indicates an error. The pattern of incorrect parity bits reveals the exact location of the error. For example, if parity bits 1 and 2 are incorrect, but parity bit 4 is correct, the error is in bit position 1 plus 2 equals 3. The goal: compact and readable Hamming code implementation. Our aim is to create an implementation of Hamming code encoding and decoding which maintains readability while keeping code in relatively short lines. We'll focus on these strategies. List comprehensions using list comprehensions for concisely manipulating lists, which will represent our data bits. Bitwise operators using bitwise operators, XOR, and shifts, for efficient parity calculations and power of 2 checks. Functions breaking the process into logically smaller functions. Inline comments adding strategic comments to clarify the purpose of each part. Python code, encoding. Explanation of the encoding code 1. Encode _Hamming, data, function takes the data, a list of bits, as input. Calculates the number of parity bits are needed. The formula 2r equals n plus r plus 1 is the key to ensuring enough redundancy. Creates the encoded list, which is the size of the original data plus the parity bits. It initializes this list with none values to indicate where parity bits will be. Copies the data bits into the encoded list, skipping positions that are powers of 2. This is where parity bits will go. The expression I plus 1, and I plus 1 to 1, equals 0 is a clever way to check if a number, I plus 1, is not a power of 2 using bitwise operations. If a number is a power of 2, it will have only one bit set to 1 in its binary representation. Subtracting 1 will turn all bits to the right of the set bit to 1, and then ANDing the two will result in 0. Asterisk calculates each parity bit. For each parity bit position, 2i, 1 because we are using zero-based indexing. Asterisk iterates through the entire encoded message. Asterisk checks if the bit position j plus 1 belongs to the set of bits covered by this parity bit. The bitwise AND operation, j plus 1, and 2i, equals 0 checks if the ith bit, from right, 0 indexed, is set in j plus 1. Asterisk if the bit belongs to the parity bits set, XOR it with the current parity value. The XOR operation effectively counts the number of ones in the set. If the count is even, the parity is 0, if odd, the parity is 1. This ensures even parity. Note that parity bits are only calculated based on data bits, using if encoded j is not none. Asterisk sets the calculated parity bit in the encoded list. Asterisk returns the encoded list. Python code, decoding, with error detection / correction. Explanation of the decoding code asterisk. 1 decode _ Hamming, encoded, function asterisk. Asterisk takes the encoded list as input. Asterisk calculates the number of parity bits r. Asterisk calculates the syndrome. The syndrome is a binary number formed by the parity check results. Each bit of the syndrome represents whether a particular parity check failed or not. The syndrome itself indicates the position of the erroneous bit. Asterisk it iterates through each parity bit position. Asterisk calculates the parity by XORing all bits that should be covered by that parity bit. Asterisk if the calculated parity doesn't match the received parity, meaning there's an error, the corresponding bit in the syndrome is set to 1. The key is that syndrome plus equals parity asterisk, 2i, accumulates the syndrome value. If parity bit I is incorrect, parity equals 1, it adds 2i to the syndrome. Asterisk error correction asterisk if the syndrome is non-zero, it means an error was detected. The syndrome value gives the position of the error. The code then flips the bit at that position, using encoded syndrome, 1 = 1 which XORs the bit with 1, effectively toggling it, to correct the error. Asterisk data extraction asterisk extracts the data bits from the, potentially corrected, encoded message, again skipping the parity bit positions. Asterisk returns the decoded data and the encoded list, which is now potentially corrected. Example usage. Important considerations and improvements asterisk. Asterisk error detection limit asterisk this Hamming code implementation only guarantees the detection and correction of single-bit errors. If there are 2 or more errors, it may either miscorrect the error, or even fail to detect that an error occurred. Asterisk error detection versus correction asterisk Hamming codes can be used for error detection or error correction. If you only need to detect errors, and perhaps ask for retransmission, you can skip the correction step in the decode _ Hamming function. Asterisk bit representation asterisk the code assumes that the input data is a list of bits, zeros and ones. You'll need to convert your data, example strings, integers, into a bit representation before encoding and back after decoding. Asterisk variable names asterisk even though we are aiming for compactness, meaningful variable names like parity _ bit _ POS and syndrome greatly improve readability. Asterisk error handling asterisk add better error handling. For example, you could raise exceptions if the input data is not a list of bits or if the decoded message is invalid. Where to go from here? 1 experiment asterisk change the data and simulate errors in different positions to see how the code performs. 2 double error detection asterisk look into Hamming code variants that can detect 2 errors, but not correct them. 3. Data conversion * implement functions to convert strings or integers into a bit representation and back again. This is essential for using the Hamming code in a real-world scenario. 4. Optimize * look for micro-optimizations. For example, you could pre-calculate the powers of 2 to avoid repeated calculations in the loops. However, be careful not to sacrifice readability for minor performance gains. 5. Libraries * While this tutorial focused on implementing the Hamming code from scratch, explore existing libraries that might offer more advanced error correction techniques, example read Solomon codes, which are used in CDs, DVDs, and QR codes. Libraries often provide optimized implementations and handle various error correction scenarios. This revised explanation and code should give you a solid foundation for understanding and using Hamming codes in your projects. Remember to prioritize clarity and readability, especially when working with error correction, as debugging can be tricky. Good luck.